Tuesday. Today we are going to do combined loading. But before that,
Sorry, Eugene, is this going to be part of the exam?
yeah, this is going to be part of the exam. All right. So let's talk about term test 2. Okay, so it'll be on July 11. It will start at 7 o'clock p.m. to 9:30 p.m. and location is in Bird Science Building, room 138. Okay. Right. So just a quick reminder, the test is in person. Okay. So today we're going to do a topic known as combined loading of structure. So you'll see that this topic this chapter is basically combine what we have learned for the past 9 weeks. Okay. And excluding buckling. Okay, excluding bucking. Okay, what we have learned for the past 9 weeks. Okay, so let's look at combined load. What do I mean by combined loading? Okay, so I'm going to get this example. Okay, we're going to look at this example on combined loading. So when a structure is under combined loading, as you can see over here, right? This is a structure. Okay, so the figure shows a structure under combined loading. And as you can see, for this structure, okay, combined or combined loading, comprise of a combination of axial loading, bending moment, shear stress or shear force, and torque. Okay. So for this case, what you see in the figure, there's no torque. Okay, for this case, there's no torque. But what we have are axial load, bending moment, shear force, and torque. Without torque. Okay, so we only have axial loading, bending moment, and shear force. So this question asks us to determine. Okay, so today you're going to learn new term, the principal stresses and the maximum stresses at point A. Okay, and we're also going to do point B. Now, this is how a structure is loaded most of the time. Now, if we look at a material handbook, okay, so these are information from a material handbook. Okay, so you get any material handbooks. For this case, we're going to focus on steel. What you will see over here is we have a table and they give us the steel type. So you will have what steel? Okay, so you have structural steel, for example. They inform us of the density. Okay, inform us of the ultimate strength in tension, in compression, in shear. They give us the yield strength in tensile and shear, It also gives us the modulus of elasticity, modulus of rigidity, coefficient of thermal expansion, and percentage of elongation. Okay. So at the end of the day, right, we have to use this data, right, to select the material for this structure. Okay, for this just an example. Okay, so we only know that, for example, we only know that this is made of steel. Okay, but we have to relate to what is given in this table. Okay, now before I go on, let's talk about this table. Okay, so this table, what you can see is you can see that we are given the ultimate strength. Okay, we are also given U strength, right? So if we go back to fundamentals, if we look at stress strain curve, okay, so if we look at stress strain curve, so we know that on one axis, okay, we have one axis over here, and then we have the other axis. Right? So this is epsilon, this is stress. So epsilon represent normal strain, and strain is unitless, and they have stress. This is our normal stress. And the normal stress, it can be Pascal or it can be PSI. Okay. So if you look at a typical stress strain curve, what we have initially is a linear relationship, right? And then once it passed the linear relationship, we have a relationship going like this. Okay. And then what we have is what we call fracture. So the linear section of a stress strain curve, which I'm going to, hold on, I need to do something on my computer. My screen is kind of dark. Right. So what we can see in a linear section where my green line stops. Okay. Right. We have a linear section, and our linear section over here, this is our U strength. And then at the peak over here, this is our ultimate strength. Okay. So we are given two values, okay? And one value is, let's focus on tension for now. And we are given a tension of 400 megapascal, and then a tension. So the 400 is the ultimate strength, and the 250 is the U strength under tension. Now, when to use U strength and when to use ultimate strength. Okay, so we have to be very careful down here. Okay, let's focus on this table first. Then we focus on the combined loading later on. Okay, so under, if we look at factor of safety, it can be equal to the ultimate strength divided by the allowable strength. Okay. Or the factor of safety can also be due to its U strength divided by allowable strength. Now, usually the allowable, say I would say note, the allowable strength is usually calculated, okay, and the ultimate and use strength are determined experimentally. Okay, so what you see is we have our tensile in ultimate strength, and we have tension in our use strength. Okay, so now when to use, so if you look at the equation over here, when to use ultimate strength, okay, when do we use the ultimate strength, right? And then when do you use strength? So in general, for ductile material like steel, aluminum, and brass, okay, the factor of safety is calculated with the use strength. Okay, you use this expression over here that I'm highlighting in yellow. Okay, so why is that? Okay, this is because the stress yield is so much lesser than the stress ultimate. Okay, so if you look down here, the use strength, okay, is so much lower than the ultimate strength. Okay, so if the use strength is lower than the ultimate strength, okay, we always tend to use it for what? Ductile material. Okay, so for brittle material, okay, like ceramic, okay, or cast iron, okay, factor of safety can be determined with its ultimate strength. And why is that? Okay, this is because the stress yield is approximately equal to the what? Ultimate. Okay. So if you see your yield strength very similar, okay, then and with the ultimate strength, okay, you can use the ultimate strength. So brittle material, for example, if we go back to this diagram, so brittle material, what you'll see, like ceramic or cast iron, you'll see that the Young's modulus is very high. And then, oops, sorry. You see the Young's modulus is very high, and then you have this strength. Okay, so this is your U strength, and this over here is your ultimate strength. So as you can see down here, the yield strength and